Hello everyone, I'm Fatima Safi and today we are going to discuss the solution of the NAT internal 2 question paper. Here, the first question is, we have to find the value of df by dx at x is equals to 3 and d2y by dx squared at x is equals to 1 with the help of the given table in which the values of x, x1, x2, x3, x4 and x5 are given and the corresponding function y at those points are given. To find the solution, first we need to make the forward difference table. To make this, we just simply need to subtract the upper value from the lower value to get the next value. The first set of values we get is delta f, and similarly then delta square f, then delta cube x, and so on. Then we also need to use the Newton-Gregory equation, which is f of a plus hu is equals to fa plus ufa plus u into u minus 1 by factorial 2 delta square fa and so on. Here a is the first value of x which we need to consider. H is the uniform interval between the values of x, and you can be any arbitrary float. So we can find the value of function f at any point of x using this formula. We first differentiate the above formula to get f dash a plus hu is equals to 1 by h delta fa plus 2u minus 1 delta square fa by factorial 2 and so on. We call this as equation 1. Then again by differentiating it we get f double dash a plus hu is equals to 1 by h delta square fa plus 6u minus 6 by factorial 3 delta cube fa and so on, and we call this as equation 2. Now we need to find, we know that x3 is equals to 0.27, and we need to find df by dx at x is equals to 0.27. That means we need to find f dash x3 f dash 0.27. For this we assume that a is equals to 0.26 and h that is equals to 0.01, so we get a plus hu is equals to 0.027. Thus we can find the value of u, which comes to be 1. Then by putting that value in equation 1, we can get f dash a plus hu, that is f dash 0.27, which will be equals to 0.9650. That's the answer of the first part. Then we need to find f double dash 0.25. So we take a is equals to 0.25 as in the question, and h is equals to 0.01. We got u is equals to 0. Again by putting u is equals to 0 and in equation 2, simply we can get f double dash 0.25, which comes to be equals to minus 6.6. That's the final answer. Now we move on to second question. In this we need to integrate the function fx using Simpson's rule. We know that there are 10 entries given in this table, and we also know that Simpson's rule can only be applied when the total number of values are odd. Since the total number of values are even, we need to apply 2 rules to get the final integrated value. So we apply the trapezoidal rule on the first 2 values and the Simpson's rules for the rest. According to the Simpson's rule, the s is equals to summation of I is equals to odd numbers h of fi plus 4f I plus 1 plus f I plus 2 whole divided by 3. That is equals to h is equals to f1 plus 4f2 plus 2f3 plus dash dash divided by 3. And by the proposed rule, s is equals to summation of 1 to n fi plus fi plus 1 into h by 2. So for the final integrated value of integration from minus 0.6 to 0.3 f of x dx is equals to h into 4 plus 2 by 2 plus h into 2 plus 12 plus 16 plus 16 minus 4 plus 8 plus 6 plus 20 plus 8 divided by 3, where we know h is equals to 0.1. So we get the final integrated value as 3.1. Now we move on to the next question. In this question, the population in the following years are given, and we need to predict the population in the year 1925, 1975 and 1985. Again, we make the forward difference table as we had made in the first question, by subtracting the upper value from the lower value and getting the next value. Then we have also used the Newton-Decreevy formula as fx is equals to f1 plus delta f1 x into x minus 1 into h, and so on. Then we substitute x minus x1 is equals to uh plus x, and we get fx is equals to f1 plus delta f1 u plus delta square f1 u into u minus 1 by 2, and so on. First we need to find f of 1925. So we take x1 is equals to 1921. We know that h is equals to 10, so we get the u is equals to 0.4. We simply substitute u is equals to 0.4 in this equation Newton-Decreevy formula, and we get f of 1925 is equals to 36.7. Now we need to find the population in 1975. As we can see from the forward difference table, that 1975 value is near the end of the table and not from the beginning of the table, so it is very practical to use the backward difference operator to find the value of population in 1975. So by backward difference formula, we get fx is equals to f7 plus backward difference nebula f7 x into x minus x7 by h plus nebula square f7 x minus x7 into x minus x6 by 2h square, and so on, where uh is equals to x minus x7. So we can find the value of u by substituting the values 1975 minus 1981 by h, which is equals to 10. We get u is equals to minus 0.6. It had to be negative, was obvious. Then we simply substitute u is equals to minus 0.6 in the above formula, and we get the nebula, the value of nebula from the lower diagonal. It's 100, 100, 136, 182, 228 and 273. We simply substitute the values here in the formula, and we get the final result of f 1975 is equals to 124.28. Now we need to find the value of the population in the year 1985. As we can see in the question table, that 1985 lies outside the range of years, so it's not the question of interpolation. But if we assume that the similar pattern is followed in the future also, we can find the value of population in the year 1985 by the same procedure, by using the backward reference formula. Here we will get the u positive, which is equals to 0.4. Then we simply substitute the value of u in the backward difference formula, and we get the value of f at 1985, which is equals to 432.486. Now we move on to the next question. In this, there are three simultaneous equations are given, and we need to find the values of x1, x2 and x3 by using Gauss-Jordan method. First, we need to make the coefficient matrix for this, which is simply the matrix of the coefficients and the constants. And for our convenience, we change the order of the equation 1 and 3 to get the highest value at the top. So we get the final coefficient matrix is 4 to 1, 1, 1, 4, minus 2, 2, 0, 2 and 0, minus 5 and 15. We apply some row transformation to make the lower triangle 0. we change the row 2 to row 2 minus row 1 and row 3 to row 3 minus row 1, and we get this matrix. Then we need to make this 7 zeros, so we again use a row transformation. R3 is equals to R3 minus 7 R2, so we got the lower triangle 0. Then we also need to make the upper triangle 0, so we make these 3 row transformations, and finally we get this matrix. In this we can see that the upper and the lower triangle of the matrix is equals to 0. Then simply by substituting these values in the equation, we get x1 is equals to minus 110 by 36, x2 is equals to 80 by 12, and x3 is equals to minus 200 by 72. And this would be the solution for the question. Thank you. For any further queries, you can comment on the link below. Thank you.